Hello and welcome to the Car Care Nut channel. So this is a 2008 Lexus ES350. The owner brought it to the shop because they have no AC. So we're gonna tear the entire interior out of this car to fix that problem, and we'll talk about what's going on and how to diagnose some AC problems that are common with Toyota and Lexus. And this video will be long because we're gonna tear this car down all the way down to its studs, as they say in the construction business. Let's get to work.
So let's grab some popcorn once more and let's talk AC. So air conditioning in cars have one very common failure that majority of people have already dealt with once or twice in the life of their cars. The refrigerant leaks out. A lot of people call it Freon. Freon is actually a brand, and that's kind of got associated with the name, but let's call it refrigerant. In modern cars, there are two kinds of refrigerant currently today being used in cars. There's R134A, and then there is R1234YF. Before that, we used to have R12. R12 is super harmful to the environment because, again, we could develop leaks here. R134A is also harmful to the environment, but at a much lesser degree. R1234YF, which is the newest stuff, right around 2016 in Toyota land and up. Not all cars, it depends, but 2022, pretty much majority of cars use it. It is a lot less harmful, if not harmful at all. It's gotten to that point. Very expensive refrigerant. The car we're working on here is a 2008 Lexus ES350 that uses the beautiful R134A. Now, every car owner in their life of owning cars, have run into this. Your AC stops working. By stop working, I mean stops blowing cold air, just hot air. You take it to your mechanic, your DIY mechanic. The first thing they do is look for leaks. Can't find leaks. Charge the system. AC works. Winter comes by. Next summer, AC is not working again. You go again. Can't find leaks. Charge it, and this cycle continues until it gets to a point where you charge it. A week later, it stops working. That's when the leak is big enough where we're actually going to find it. And that's exactly what happened with the owner of this car. See, the owner of this car have had this AC charged multiple times, but it got to a point where a week later, it just stopped. And the mechanic he took the car to, with the admittance of the mechanic and the owner of the car, not the specialist with AC. He does simple repairs, but AC is not his strong suit. So he basically told him, you need to take it to somebody who is a specialist. Well, usually with AC leaks, it's either going to be a condenser hit by a rock, that's super common, joints where a line connects to a condenser, a line connects to somewhere else, there's a little O-ring that leaks, sometimes the line gets deformed from corrosion and whatnot. These are super common failure points. Another failure point or leak point are the valves where you service the system. A lot of people skip the valves, but the valves are actually another common failure point. But the thing that bothers people is, how can you not find leaks? Folks, leaks that take 6 months to show up are really hard to find. And typically with leaks, you have an oil stain around a component, and that's how you know something's been leaking. The AC system has oil, that's for the compressor, so you're going to see that oil. Typically, in automotive repair, you're going to add a dye, and dye comes in form of an oil. So you add it as an oil. It has a fluorescent dye. You can see it with a black light, and that's the green stuff. You're going to see it later in the video, but you hope that you can see this dye leaking from somewhere, and that's how you identify the leak. This one, however, had an interesting leak from the evaporator. That's why I'm pulling everything. You're going to see all that toward the end of the video, and let's get back to show you with the dash pulled, and we'll go from there.
Well, here's the dash. This is just the first layer, and this is the easy part to remove. This is basically what you would do if you're replacing the dash, if this has a shiny dash. I do have some doubts that this dash might have been apart before. Maybe because of the shiny dash issues that they've had. Perhaps this has been apart, because there's a few signs that things have been apart. Maybe it's just me. We'll run it by the customer. But this is the dash, in case you haven't seen a dash on a car. This is how it looks like. We've done a dash video before, but I just wanted to run this by you, show you how they're all the same. Here's your AC vents. Here's your airbag for the passenger side. And it's just very, very simple. Now, you saw me working a little bit under the hood, and I wanted to show you what we were doing under the hood. So we're going to remove the whole AC box. So the first thing we did was disconnect the AC lines. Even though this is empty from AC, I just wanted to make sure there's no remnants of gas. So we disconnected the AC lines right there. We drained the coolant. We do still have to disconnect the heater hoses, which are on the other side right there. Right over there. We have to disconnect them yet. I haven't disconnected them. But let me show you inside the car, and this is where the operation starts, I suppose, if you want to call it that. So this is what we have. And usually when you do a dash job, this is super simple. Very, very simple. I'll go from the other side so you can see, talk about this. So all Toyota and Lexus are built almost the same. You have your dash pad, which you just removed, that's the official term for it. And then we have steering column, that's gonna come out next. And then you have your support brace. This is actually a brace that holds the body. It's connected on the outsides with bolts. And then we have all this wire harness connected across it. You have your body ECU right there next to the steering column. And then you have another junction block on this side. Behind that, the white part that you see here, this is the air conditioning box. This is where your evaporator is. This is where your heater core is. And this is what we are removing. So the next order of business is remove the steering column completely out of the car. Start working on this harness to remove it out of the car. Remove this bar that goes across. Then start loosening the AC box to pull it out so we can change our evaporator. Quite an operation, not really super difficult. It's just, it requires patience, it requires kind of finesse and attention to detail. You don't, no bolts left behind here, of course, because that's how these things start rattling. But without further ado, having said that, if you haven't seen one, this is how it is. You're gonna see it. All this will be out of the car in midpoint of this video. Let's get to work.
Let's talk about AC charging as we take the rest of the car apart, because there's a lot of misconceptions about this. Many people assume AC charging is very simple. It's just a very simple process. Anybody, you don't even have to be a DIY mechanic. You can just do it yourself. Life is good and save all this money. Just go to a parts store, buy the little can with the gauge, and life is good. Folks, I cannot tell you how mistaken you are if this is how you assume things are. AC is not difficult to charge, but there is a lot involved in it. Number one, the EPA and the environment. Something about refrigerant. You notice when you go to a parts store, they won't sell you more than a pound of Freon in this little can you buy that, by the way, is super overpriced. But the reason for that is you actually need a specific certification, at least in the USA, to buy more than a pound or buy the 30-pound container that you'll see professionals use. It's a very simple test, nothing to it, but you need to be certified. You need to know the dangers of refrigerant to the environment and to yourself as well. But let's talk about charging AC. Most people get this can and hook it up and has a gauge, has a little green thing, and 99% of the time that gauge is highly inaccurate and it's very vague. See, refrigerant has certain properties with pressure, and that's how you really check refrigerant. But there are so many other things that affect it that it becomes super inaccurate. For example, all this gauge is looking at, you want to be somewhere between 30 and 40 psi when your AC is running. But the problem is, what if the AC is not running? What about variable compressors that really vary the pressure based on the conditions and the demand? This is where this becomes a problem. If you own a 1990s car, yeah, more than likely, you're going to be able to use that gauge, that little inaccurate gauge, and get close to the correct level. But if you live in a very hot area and you have a modern car with a variable compressor and all this, a flow valve and all this stuff, it's not going to be accurate. And if you overcharge this AC and you have high demand, the pressures will go through the roof and now the AC will just shut off. If you undercharge it, same thing. It's just going to keep cycling, and it's not going to work right. And it gets to a point where, especially if you have leaks, You charge the car, you spend a small fortune in this little can that costs easily 3-4 times more than what you would pay for refrigerant at a shop. And then it leaks out, or worse, the AC stops working again for another problem, and now you go buy another can and try to charge it more, and it doesn't take a charge. And of course, you can't return these cans. You end up spending more than what a shop would have charged you to properly charge this system, properly diagnose this problem. And when I mean properly, you saw that big machine that you can see it right now in the shop. That big machine is a calibrated machine that takes the refrigerant out, puts the system in a vacuum for at least 25 minutes. The idea here is when you put a system in a vacuum for 25 minutes or longer, you actually start boiling any moisture left behind, in case there is any. But then it does something very important that most people also miss. Even shops miss this sometimes. It measures how much oil came out of this car, so you can add that same oil back, because then you're going to run the compressor low on oil. Folks, when it comes to AC, charge it properly. I advise you not to use the little cans because they're highly, highly inaccurate.
So here we are, folks. Let's talk about the AC a little bit. There's an evaporator here. There's a condenser in the front, and there's lines in between them, and actually there's an expansion valve, which is a part right here. Very simple operation for the AC. This is the AC drain. This is actually what drains the condensate out. When you have an AC leak, just like we talked about, when you have an AC leak that is mysterious, compressor is good, lines are good under the hood, your condenser is good, and you see nothing, and you keep a month, AC stops working. You go to a mechanic. Oh, let me charge it again and again and again. Look at the AC drain. And if you look at this one, you can see there's oil all over it. This is actually oil from the AC system because the evaporator is leaking and there's water coming down, and that oil eventually, it will mix with the water, but it'll eventually come down this tube and you'll see it collect here. But sometimes it does not, because if it's a small leak, it won't. But when it gets to a big leak like this one, it's gonna collect, and this is all oily at the tip. Something about Toyota AC boxes. They're actually two pieces. This is the evaporator heater core case, and this is called the blower unit. So this is where the blower motor is, and this is where all your doors for the mode, for feet up, whatever, the windshield, all is here. These are separated, and we're going to separate them right now because, let me show you a little bit close up. This is your expansion valve right here. This is where your evaporator lives. This overlaps it, so we're going to have to separate this so we can get this cover off. But this, on this side, is where your heater core is. These are two coolant lines. We have them capped, so when we pull it inside the car, it wouldn't make a mess. But this is where your heater core is. This is called a servo motor. This is what moves the doors inside. You can see the gear right here. This is just a motor that moves, turns, and this gear turns with it. This is the inside temperature sensor. That is pretty standard on Toyota to see those. It just checks the air temperature. It creates a suction here, and there's a sensor right there, and that's what checks the inside temperature. Now when we flipped this, some oil came out from inside the evaporator. That's normal. We actually should clean it so it wouldn't make a mess. See some of it? And you notice the oil is green. This is dye. Dye gets added to AC systems to detect leaks easier. Usually, big enough leaks, even if you don't have dye, you'll see them as a big oil stain on one of the AC components. Having said that, let's dig into this, and we're going to do this live. These are the tiny, cute connectors. They're actually odd connectors for the servos. That's just unplugs right here. Then we got to make sure we undo this wire. And there's one more wire going that way. Which this wire, you gotta be careful with your wires. This wire goes all the way out here. This is what actually is the main wire that connects all the servos together. There we go. One more. There we go. Now we have separated everything. We're going to take these two 10mm bolts. Now, a little bit of a fight. Everything is a very gentle fight when you work with the AC box. There you go. This was not a fight at all. This is the blower unit. This is the blower motor right here. This sits like this in the car. This is your fresh air intake. And you see there is a servo motor right here. So when you press fresh air in your car, this motor is going to move this door. See this door, how it moves? To either let air come from the outside, and then it flips. This door flips all the way up, closing the outside, and now your air comes through here. And for those who do DIY maintenance, this is your cabin filter right here. A little bit dirty. We're going to go ahead and replace that. It's much easier to do it this way, don't you think? To replace a cabin filter like that, just when the unit is out. Let's put this to the side. And then now that the blower unit's out of the way, let's talk about the servos. Most Toyotas will have 4 servos, at least the ones with dual climate control. One less if you don't have dual climate control. You already saw the other servo for the fresh air. 2 of these are called blend servos. One for the passenger side, one for the driver's side. And what these do, they blend hot-cold. They control that. The other one, which is this one, the top one, well, actually this is the bottom one, we're looking at this upside down, but this one controls, this is called the mode servo. So this is what controls where the airflow goes, to feet, to face, combo. This is what controls that. We're not going to take any of these apart because we are only interested in the evaporator. So to start that, I'm going to get some of our wire out. Okay. There's a few screws and a few clips, and this guy should come right out. Now that we have all our screws, if there's any moment when if you're ever doing work like this, if there's ever a moment you want to be gentle and careful, this would be it. There you go. I'm going to flip this because there is a temperature sensor or a thermistor or whatever you want to call it. This has to go in the exact same spot. So what I normally do is I mark it. Put a mark. Remember, this evaporator is garbage. So put a little mark right at the top of it. And now we remove it. There's that thermistor, and here's the evaporator. Before we pull the evaporator out, we're going to want to take our expansion valve, which is this one. our evaporator comes out. And would you look at this? This whole job is caused by this. I hope you can see it very well. This is drenched at the bottom, not so much on this side, but on this side, here it is. There's your leak. You can actually tear into this. You can see the oil all sitting here. It's leaking at the bottom, probably in this corner right here. That's all it takes, folks. Actually, it's drenched right here. That's it. This is what caused this car to keep losing its AC, losing its AC, losing its AC. And this drains into the bottom of the case. And when you look at this bottom of the case, see the oil right there? This all runs down, comes down, and goes through the tube. And this, incidentally, happens to be the moldiest, ugliest area of the AC system, because this is where they always have water. Water in a dark place equals humidity, equals mold and mildew. And this is what causes the bad smell in these cars. Before we go in the car and I'll show you this, let me just wash my hands because we've been touching this mold. We're going to clean this properly. So here is the car down to the studs. Except this stud, this one stays. This is actually the brake pedal. This is the steering shaft right here. It's disconnected from the steering column. Toyotas have three-ish main harnesses. One of them is this one. This is called the dash pad harness. This is the one that is most difficult and most expensive to replace. I mean, you saw, I didn't even remove it from this, and it's still this much work. And this actually wraps, goes underneath the seats, comes all the way here, goes underneath that seat. That's why we did not remove this all the way from the car. Then there's a second wire harness, which is this one. This is, I would call it the body electronics outside or front. This goes to the fuse block under the hood, goes all behind the bumper, wraps around, and then it also comes on that side of the car. Enters again. These are the 2 points of entry, one here, one right there. Then there is the engine harness, and then there is two floor harnesses that one runs across each side, goes all the way to the back. That's all the wire harnesses in Toyotas. That's how they are. You see the file, he's showing you the, Eros is showing you the floor harness right there. There's one also here. Very simple. Every single Toyota will have the exact same design. Once you've done a few hundred of these, they all come apart the same way, exactly the same way. This is why Toyotas are good cars, folks, because they just don't change. This is a premium Lexus. You go to a bare base model, bare bones, manual windows Yaris, it's exactly the same way. It's exactly the same setup, and that's why they get it right every time. There is one thing that is very interesting. This little guy. Very innocent looking computer. This is called the ID box. If you go to the dealership and buy yourself one of these new, you can basically steal any Toyota just by accessing it. That's why Toyota put this behind the AC box, and I'll show you where it actually mounts. It literally mounts right here between the AC box and the firewall. I don't remember the last time thieves broke your window, opened the door, did this whole job just to replace this so they can steal your car. But folks, this is the ID box. I remember a technician, very dear technician that I worked with for years, did a 4Runner, same job, same evaporator, all that, forgot to plug this in after the car was all put back together. That's not a bad moment, and that's why we're going to remember to plug. This one is already plugged, but we have to clip it. And where this guy clips is on the evaporator itself, actually the case. That ECU, the ID box, clips right here, and this goes against the bulkhead or the firewall or whatever you want to call it. Let's take a small tour before we start reassembling this whole thing. Here's the dash. You saw the dash already. Here are all the parts that it kind of took to pull this thing out. There is your steering column, in case you haven't seen a steering column up close before. Here's how that looks like. There's various interior parts. All of this is super easy to remove. Really, the hardest part is dealing with that bar and how it comes out in the ID box and washing all your wires and washing your interior and all that. Some folks will say if you remove the seats it'll be easier. Yes, but then your back will be sore because you have no place to sit while you're taking things apart. I'd rather do it this way. It's much easier. Every technician will have their opinion on that, and there is that. Difficult job because this requires extreme attention to detail. You forget things, you're going to have problems, you're going to have rattles, you're going to route wires wrong, you're going to have problems with wires getting cut. Takes time, takes experience. Definitely not a DIY job. It could be, because you notice we don't really need a lift to do this, but this is the kind of job you might want to leave for someone who's done this before. And Eros is the person who is filming right now, in case you don't know who Eros is. He is my awesome teammate here at the shop. He's amazed because he's seen a dash come apart before, but haven't seen a car come to its studs, if you would. This is construction land, this is what they call it. But we're gonna go ahead and time-lapse you through reassembling this box, kind of cleaning it up a little bit, and then putting this whole thing back together as we carry on our conversation.
Let's talk about the costs of this job, then we'll continue our conversation about charging AC. So the cost of this job is right around $1,600. Some people's hearts have just dropped, but this is a big job. This is a labor-intensive job, not really parts-intensive job, although it could be. The Evaporator original from Lexus was right around $330. The coolant, which we used 2 of those to refill the system, original coolant, was right around $28 per gallon. We took 2. Cabin filter was right around $21. Refrigerant was $13 a pound. So that's a grand total of $26 to charge this car. You go buy the refrigerant to charge this car outside, it's easily going to be 3 times that, because you're going to need 2 cans and you're going to need to buy the gauge. And then by the time you're all done, you would have actually spent more to charge this car inaccurately than you would have with a good shop charging the car. But anyways, labor was right around 10 hours. It took us just under 10 hours. I've done a lot of these, so this is someone who is experienced doing this. I've done this before. I'm not gonna keep reading the manual and going back and forth, but this is almost a break-even job, even with experienced technicians. It's labor intensive. You really spend time. If you really look through the time lapse, there are times that I put something together, I don't like how the wire is routing, I stop, I go look at my picture, and it just takes long. This is a job you don't rush through. I remember from the dealership days, every technician who was impatient usually had problems with this job, because when you see something not going right, that's the point you stop, you reverse track, and don't be lazy or in a rush to start taking things apart again just to make sure it's right, because you route one wire wrong here. And in the end, right around when you're plugging that last component, it won't reach. Now you have problems. You got to take the whole thing apart. So this is a job for the patient, not for the ones in a rush. That's one thing important here. Now, let's talk about charging your AC, and should you charge your AC or service your AC system, because this is another one that I see so many customers ask me about this. I think it's the biggest ripoff in the planet. So your AC system is working perfectly fine. No leaks, charge levels correct, has never had problem on your 10, 15-year-old car. People have a tendency of falling for this, for lack of a better word, it's a scam. Okay, you need to service your AC. Why do you need to service your AC? Well, AC has moisture. Moisture affects the AC operation. Well, usually at this point, 99% of non-mechanics, non-car people have already fallen for this one. Oh yes, that makes total sense. We have moisture. We can't let it. It's going to corrode things and everything, and that's no good. Well, here's a logical question for you. If we have no leaks and we have no air in the system, we only have refrigerant in a sealed system, where exactly would the moisture go in from? That's the question here. And in case there is that very, very minute amount of moisture that made it in when the factory filled it up, which is not really the case, but let's go with it. If there is a minute amount from the factory that moisture doesn't suddenly expand on its own, there is actually a dryer in these systems that usually would capture that moisture and trap it, and there it sits. So if your AC is working, I don't care how old your car is, 20 years old, you're the original owner, the system has never been opened before, then it never been opened and it stays. Because there is no need for you to service the AC if it's not broken. If it ain't broke, don't fix it. If all of a sudden you notice your AC performance is not good, you have a leak. When you have a leak, sooner or later, it's going to stop working completely. That's a different story. But if you have no leaks, AC works perfect even in the hottest days. Don't do anything to it. If anything, if you open that system and recharge it with contaminated refrigerant or with a contaminated machine, that's the worst thing, or an inexperienced technician who is impatient with the machine, never open the lines, never put it on a vacuum, didn't do things right, didn't let the machine go through its correct cycle, you now have moisture in the system. The machine we're using here, some people within the industry, friends, dealership, not principal, service managers, whatever, have called me crazy for buying that machine. That machine is probably one of the most expensive machines you will ever see in the automotive industry. It can handle both refrigerants, but I bought it not for that reason. I bought it because it is a highly accurate machine, and the most important thing is it has an identifier. What that means is you bring me your car that 7 other mechanics with their highly contaminated machines have been charging your car with. Well, I evacuate your car, put it on a 25-minute vacuum, charge it. Well, guess what? I just contaminated my machine because of your car that has been contaminated by somebody else. Then the next customer shows up, we do a job, I just contaminated their car as well. And this goes on and on and on. But this machine has an identifier. If this refrigerant is contaminated, the machine will pick it up before it contaminates itself. In that case, I use an external recovery tank. So basically, this refrigerant goes out of my internal tank of the machine. So now I can dispose of that contaminated refrigerant, flush the machine, and this is all within this machine. So I wouldn't contaminate the car that I'm working on after the repair or the cars afterwards going forward. Now, I've worked in the automotive industry, and majority of places that are owned by decent people, they will take care of their AC machine. They will not recover a car into their internal tank with, for example, a compressor that blew up and threw debris all over the AC system. They will not do that because this machines cost a small fortune and they want to protect it and take care of it. But we come to a problem with dealerships, and I will say this. Dealerships usually have 1 or 2 machines that are the top of the line machine, the best of the best. But the problem is you have 20, 30, 40 mechanics working on this dealership that none of them paid for this machine. They don't treat it right. I see technicians cut the procedure in half because they're too impatient to wait the 25 minutes for the vacuum. I've seen technicians mistreat the machine, hit it, throw it, bounce it. I've seen technicians run over the machine with a car. I mean, it's mistreated all the time. And the dealership, because they have so much expenses, they're not going to do anything with this machine. No maintenance, no nothing, until it completely dies. That's the problem. That's when we have problems. And I remember distinctly, I worked at a dealership. It was a struggle to keep that machine in good shape because you just have people mistreated. And what are you going to do? You have a lot of technicians. You're trying to find out who's mistreating it. It's really difficult. The machine is just sitting there. Many people use it every single day. This is the problem. You need to have a very accurate machine here. This is where what makes or breaks AC repair actually is the well-being of that AC machine. Is it accurate? Is it calibrated? Is that there's a filter in these machines, a dryer that needs to get replaced? Was it replaced? That's where this becomes a problem. And something about recovering refrigerant. This machine recovers the refrigerant, tells you how much came out of this car. And in the case of my machine with an identifier, it's going to tell you exactly what came out of this car, what kind of refrigerant, how much air was in the system, and if there's any contaminants. The other thing is, it's going to tell you is how much oil you recovered. This is very important. Most people miss this. I see this, people miss this all the time. Basically, if you're not replacing large components like evaporator, you're replacing a line. Typically, a line will not hold a lot. Wherever you oil you got, you re-inject back into the system. The other thing is, you need to leave this system for at least 25 minutes on a vacuum. The reason for that is, at that high vacuum that this machine pulls and you leave it going for 25 minutes, it is actually going to boil any moisture left in that system. But that process is slow. You need to leave it for a long time for it to actually boil all the moisture inside the lines. So now when you go to charge it, you actually charge it with the minute amount of moisture, if any, and the minute amount of air. And sometimes with AC systems, when you put them on the vacuum, there's actually a small amount of refrigerant trapped within the oil that gets extracted as well. This is very important. The accuracy of the machine is what makes or breaks this beautiful repair, makes it just useless. There's no point. Folks, I highly advise you against the self-service kits. They work. Sometimes they work, but they never work right, because these machines, when they charge, you tell them exactly how much you're charging. And the most important thing is, these machines, they actually have a compensation. So you charge this car. Well, what about the refrigerant that's left in the hoses? These machines have a scale and they know how much refrigerant left. But what about the refrigerant in the hoses? Well, the modern machines, or the automatic machines, once you're done charging the car, it's actually going to tell you, turn the AC on, leave the low side connected. What that's going to do is going to pull the refrigerant out of the two AC lines from the machine to the car. That's called the compensation, because that's part of the charge that you charge the car with. These little details is what makes this job successful or not successful. And charging with a bottle from the parts store just doesn't have this level of accuracy. It needs to be accurate, especially with modern cars, folks. Especially R1234. I told you the pound of R134A, at least in my shop, is $13 a pound. R1234YF is almost $100 a pound. So when we start dealing with this expensive refrigerant, things get really expensive, and you can't be leaking that refrigerant, because you're basically, every time your AC leaks, you're leaking $100 to $200 just in refrigerant. This is a problem. Let me talk to you briefly about how much it should cost to recharge your AC should you have an issue. It should be 1 hour of labor maximum, and the refrigerant should be right around $13 to $20 per pound. Most cars take 2 pounds. Larger the car, the more it takes. The most in Toyota and Lexus land is going to be 3 pounds. That's for something big with rear AC, and they're rare, really not a lot of them that take 3, but some do. Folks, you're probably going to end up paying less to recharge the car properly, diagnose this properly, than just do it yourself. This is one of those. And if you're doing a repair, let's say you saw a leak in the condenser, go to a shop, let them evacuate the car. Do your repair, then bring it back to the shop and tell them, just charge it for me, charge it properly, and ask them about their machine. Let them show you. This is important. You could do the best job in the repair. If the machine is horrible, contaminated, it's old, and it's not accurate, it all goes down the drain. It all means nothing. This is important, folks. And then part of the whole repair, as a customer, when you pick up your car, look around. Drive it. Do you hear rattling? Do you hear something falling off the car? This is important. Hey, nobody's perfect. Everybody makes mistakes. But you checking and picking things up, don't come back after 6 months saying something the same day. You see something wrong, say it.
So there you have it, folks. Car is all done. I am happy with it. For those that hesitate when it comes to jobs like this. Your mechanic's telling you need an evaporator. It'll never be the same. It'll rattle and all this jazz. Let's go take this car for a ride. Now that it has AC, we'll go take it for a ride. You can listen, you can see it in action with AC after this massive repair, and you'll see that this job can be done without the rattles or squeak. So without further ado, let's go for a test drive. All right, folks, let's drive the car. And as soon as you get out of our shop, there's a pretty good bump. Let's take a listen here. I hear nothing. Nothing creaking, nothing rattling. Let's go pick up some speed. We're nice and cool here. Actually, we had to turn it down. It was a little too cold because the car has been in the shop and it's air conditioned. So it's not, the sun hasn't been blaring at it for hours and hours. The only thing that we're gonna need with this car is an alignment, or I might just try to make an adjustment. The steering wheel is slightly off center because we had to take the steering column. That does happen. When you take the steering column off, you might need to tweak the toe a little bit to make it perfectly center. Let's pick up some speed. Well, it is nice and quiet. Only wind noise I hear is from the sunroof. We didn't do anything with the sunroof. Drives good, AC cools well. I don't have issues. We actually ran it on the vacuum test here for a while there before we went out. It held pretty good. Probably left it there for 15-20 minutes. It held all the vacuum, so I'm happy with this job. It turned out great. I think the customer will be happy that they will not be able to tell anything ever happened here. We're probably going to do a little bit more cleanup. Today is Friday, TGI Friday. Today we are filming this video. It's kind of hard when we film these videos and sometimes multi-weeks later you see them. Today's Friday. It is 6:21. We've been working on this, just to give you perspective how long this job took. We've been working on this car since 9 o'clock in the morning. It is 6:21. We're done. It does take longer when you're filming and dealing with all this stuff, but all in all, it wasn't a bad job. Folks, I hope this video is helpful and informative. I hope you learned something new. If you like it, consider giving it a thumbs up. If you're not a subscriber, consider subscribing to the channel. Check out some other videos. And until the next video, folks, may the Lord bless you and keep you, and you have yourself a wonderful day.